All right, so today we're going to begin lesson 5.2 on congruent triangles. We are going to start to look at exactly what it means when we say two shapes are congruent, talking about corresponding sides, corresponding angles, and also look at how our rigid transformations factor into the concept of triangles and shapes in general being congruent. All right, so first of all, we have this principle of superposition. And this is not something you need to know or memorize. It's just a fact here that for two figures to be congruent, there has to be a rigid motion or series of rigid motions that would map one figure exactly onto another. And we're going to do that a little bit today. So if two figures are congruent and they're drawn on the same, let's say, coordinate plane, there's got to be a combination of a translations, reflection, or rotation that will take one of those shapes and move it right onto the other. And that's the only way these two can be congruent, is if something like that can happen. All right. So congruent figures are Xerox copies. They got to have the exact same size, exact same shape. All right. Now, congruent triangles, we just say congruent triangles or two triangles are congruent if and only if all their corresponding parts are congruent. Now, when we talk about corresponding parts, what are we talking about? Well, we're talking about the three sides and the three angles that make up the triangle. If these two triangles, ABC and HJK, if these are truly congruent, then all three corresponding sides have to be congruent and all three corresponding angles have to be congruent. And if that's true, then we can say the two triangles are congruent. And then how we write that congruent statement matters, is important. Okay, so what you see here is they've given us everything we need to know. Okay, so these markings inside the shapes tell us what matches. So you can see angle B has this one arc, angle J has the corresponding same exact arc. So that means angle B and angle J are the same angle. You can see A has two marks, H has two marks. So that means A and H are the same angle measure. And then C and K match up. Okay. So I said down here A and H, B to J, and C to K. And then side lengths, you can see the single mark through the side, that's A to B, and the single mark through the side, H to J. So A, B, and HJ are the same length, right? The two marks through BC and the two marks through JK, I mean, they're the same. And then lastly, AC and KH, they're going to be the same. So the markings themselves tell us that those side lengths are the same. So I have 6 corresponding parts all shown to be congruent. That means the two triangles are congruent. Now, when we go to write our congruent statement, okay, if I say triangle ABC for my first triangle, then what has to happen is I have to match it up correctly with the second. So you remember, see how A and H are the same angle? So if A's first here, H has got to be first there. I then put a B second, so that means B and J were the same, so J's got to be second. And then C and K are the last ones. All right, so you got to match up the corresponding angles, and that will also match up corresponding sides. AB and HJ were the same. BC and JK were the same. AC and HK were the same. So a congruent statement is telling you exactly what parts correspond. So you have to write the congruent statement correctly. Okay. So this is just a review of our transformations. Okay. So for example, these two shapes are congruent. So what transformation allowed that to happen? Well, this would be a slide or a translation. We would slide all of these up to this position. Okay, what happened here? If these two are congruent, it looks like it's just a rotation. Okay, here, again, it's a slide or a translation. And here, by the way the images are arranged, it's a reflection. Okay, so again, that first concept I gave you talked about the fact that there had to be a combination of transformations that could take you from one shape to the other if they're truly congruent. All right, so this next one is just us working on naming corresponding parts. Again, they've matched it all up for us. Okay, they've given us the markings in here to indicate it. So our job is just to match them up correctly. So A should be matched with Z. Angle B is matched with angle X. Angle C is with angle Y. A to B would be matched with X to Z. And you could put X to Z or Z to X. It's not going to change anything. A to C gets matched with Y to Z. B to C then gets matched with X to Y. Now, if I call this first one triangle ACB, then I got to go ZXY because I got to match up corresponding parts. Okay. This will be wrong if you don't match up the corresponding parts. So that's pretty basic. All right. Now, this is kind of fun. So in this part, it says use the tools to move the solid onto the dashed triangle. If it's not possible, click not possible. So what you get here is if you look at this toolbar, um, this is a translation. So if you grab a hold of the solid, you can drag it over to here. And then if you grab this tool, it allows you to rotate it. And then this reflects it vertically. This reflects your image horizontally. So your job is to take this shape and try to map it so that it fits exactly on top of this dash line. And you can use these tools to do it. Now, what happens in this case is that doesn't work. You can't get it to work. But over here, okay, if you translate it, and then I think you have to flip it vertically, and then I think you might even have to turn it a little bit, like rotate it. You can get this solid to go right on top of the dash line. Okay, if you do it, you get the solid to go right on top. So you would say this one is possible, and it's not going to ask you, I don't think, which ones that it took, but you get to actually use these tools to do that. All right. This is similar. The difference in this one is not only are you going to do the translation, you're going to take this image and move it over here and make it fit, but you got to then track the vertices so that when we name our corresponding parts, we match it up correctly. All right. So this is going to be the process. They're going to say, first of all, take this image, right? Oops. And use the translation tools down here to get it to fit right on top of here. Once you do it, then match up your corresponding parts. And what would happen is angle E would match up with angle L, angle F would be with angle J, and angle G would be with K. And then matching up your sides, EF would go to LJ, FG would be to JK, and EG would be to KL. And you'd have to slide it over there and keep track of them and match them up. Last part just says, are all three pairs of corresponding angles and all three pairs of corresponding sides congruent? So the answer here is yes. We just showed that we could match everything up perfectly. And because we can match all six corresponding parts up perfectly, that means the triangles are congruent. Okay. So you get a chance to work with the manipulatives and then track things. All right. So hopefully you got a chance to see that. And that's really all there is to it tonight. So congruent triangles, again, are triangles that are identical to one another, Xerox copies. All three sets of sides match up. All three sets of angles match up. And, you need to track those. And they're also done through our transformations. All right. So your homework follows very closely to the problems that we just worked on. And I'll let you have at it.